Hello and welcome to my tutorial on computer vision. As a part of the first session, we have seen how an image is interpreted by the computers. So that for my first tutorial covers about the fundamentals of the image processing. Now with that background in place, we are trying to build another application which makes use of the image processing. Now this application is very simple application, but it gives you an idea about how different components can be integrated together to build an end-to-end application. Now here we are going to deploy an Python based application which can detect movement or motion. This application can be deployed either on the Windows laptop, Windows machine, or in the edge devices such as the NVIDIA Jetson Nano. You can even deploy this on the Linux, but the best way to use this application would be to deploy it on the edge devices such as NVIDIA Jetson Nano. Okay, the NVIDIA Jetson Nano is a very powerful device which has got high, very good capability to do image processing. So that's the recommended device. But now in this tutorial, we are going to use the Windows machine. In my later tutorial, I would be deploying it on the NVIDIA Jetson Nano. So let's try to first understand the end-to-end flow with the help of this slide. Okay, so let's move ahead with this. Okay, so what you see on the left side is IP webcam or a USB cam, or you can use the integrated camera which comes with the laptop. If you're using IP webcam, then it will be using real-time streaming protocol, and using real-time streaming protocol, our Python based application would be able to receive the video or the live from the live camera. Okay, and then in the application we will use OpenCV to detect if there has been some movement or motion or some light has been turned on, and moment we detect some movement or motion or the lights turned on, we are going to take a snap of it and then send it to the cloud like AWS. At the same time, we are also going to send the SMS to the end user, and in the SMS we are going to send the time as well as the image which has been taken at the time of movement, when that movement has been detected. But before going into the details of the code, let's go through the basic logic that would be used in the Python application. So I'll try to explain it with the help of a simple flow, the flow diagram, so that you understand the things before we get into the Python code. Okay. So here it is. The very first thing that you do in the application is initialize the video capture library. That is, you're going to use the OpenCV, and using the functions in the OpenCV, we are going to get the stream of frames, that is the video from the live camera or from the IP webcam or the USB cam. So that is something which we are going to initialize as a first step in the application. Now any video is consisting of n number of frames, right? So when you start reading the videos, what you get is a stream of frames. Now in the while loop that we are going to start, you will be reading each of those frames, will pick up each of those frames and process it further. So that is why we are going to run this while loop. The next thing is that after taking the frame in the while loop, each of those frames are converted into the grayscale. Now why grayscale? This is a very common practice in the image processing or computer vision to convert any image into the grayscale, because when you have it in the grayscale, it needs less computational power, less resources, less RAM or less CPU, and it makes the things faster also, without losing the information as such in the image. So that is why this is the first thing that we will do, convert the frame to grayscale. Now when you pick the frame, there are times when it has got the noise, right? The noise can happen. Noise can be there because of the environment condition, or because of the camera which is taking the snap or taking the video, right? So that is first thing that we need to do is smoothen the image or remove all such noises. How do we do that? We use different filters to remove the noise, but in this case we are going to use Gaussian blur to remove all such noise and smoothen the image. Now, the basic idea behind this application is that you have a base image, and then the base image is taken at the start of your application, and then over a period of time you are scanning through different frames, right? So if you keep comparing the current frames with the base frame. The moment you detect that there is some difference, there is some substantial difference between the current frame and the base frame, you can assume that there has been some movement at that point of time. For that, we have to initialize the base frame in the application. That is, the moment you start the camera, you have to take the snap of the area at that time and keep it in your application so that you can use it for comparison at later stages. Now, moment you get the latest frame, what you do is you subtract this frame from the base frame. That is to find out if there has been some addition in the environment, or some new object has come into that environment, or some kind of changes are there in the frame. To know that, you have to subtract these two frames. Now, after subtracting, what you have to do is that you have to apply thrashing. That is, in this, what you do is the difference or the subtracted image will have the pixels on it, right? So what you do is you convert those pixels either to white or black. That is, pixels having a value above a certain threshold will be converted into white, and the pixels below a certain threshold value would be converted to black. And then you try to find the contours in it. What is a contour? In an image, whatever the objects are there, the outline of those objects is contours, right? So when you have subtracted the image and converted into black and white, you try to find the contours. If there is some difference, then definitely there would be some white portion in the subtracted image. That is after applying the thrashing. Find the contours, and once you find the contours, check what is the area of those contours. How big are those contours? How big will tell you, what is, how much is the difference from the base image. If the contour area is big, that means something major change has happened in the area. If this is small, then it could be just because of some light intensity change, or some very small, the movement of some very small object in that area. So that is how you find out what is the movement, or has there been a major change in the surrounding area, or it is just because of some light intensity. That is what you are going to check with the help of the contours. So if the contour area is above or below a certain threshold level, then you will say that yes, the changes have happened in the area and there has been some movement. If the contour area is below a certain threshold, you can safely ignore, because that could be because of some small change in the surrounding environment, or it could be because of some light or something like that. You can safely ignore, but you need to set some threshold for that. So that is what you can conclude, that there is some movement. But before confirming that there has been movement, you also have to see if these contours are appearing because of lights being turned on in that area, or lights being turned off. So how do you detect that? Let's say you have a tube light in that area and you switch on the tube light. Now, the moment you switch on the tube light, the contour or the area around that tube light would be very bright, right? So the pixel values in that area would be above certain threshold value, right? So if you apply thrashing on the subtracted image, and if you have that threshold value set to very high side, let's say 180 or 200, and that contour still appears after thrashing, that means you can conclude that the light has been turned on in that specific area. So you can say that the movement has been because of the lights being turned on. So this is what it is. So once you conclude that lights has been turned on, you can take a snap of it and then you can send it to the AWS for storing in S3 bucket. At the same time, you can use Twilio service to send out the message to the end user along with the time and the picture of the image taken at that point of time. So this is how the entire thing is going to work. Now after this, let's go get into the code and see how the entire thing is going to be implemented. Let's move ahead. Okay, now let's get into the code now. Code details now. This is the Python code that we have created for this application. The first thing is we have created a class called CamVision DNN, and in this class all the different methods has been developed. So in any application, initialization is the first thing that you do, right? So this is the first method that you see over here is the initialization part. So Init App is the method. So let's look into what is there in this Init App. Now, as I said earlier, that we would be using services like AWS and the Twilio for sending out the SMS and sending out the images over the SMS to the user. So to connect to those services, we need some access keys, secret keys, and the account ID. So first two you see is the access key and the secret key belonging to the AWS service. You need to have those keys from the AWS service. From your account, you will have to get those access keys and secret keys from the AWS. Likewise, there's Twilio service that we would be using for sending out the SMSs, right? So you also need to get the account ID for the Twilio and the auth token for the Twilio. So we are just initializing those keys over here in the init method. Okay. Next thing is next step we are initializing the Threadpool executor because we would be doing certain operations in parallel, right? So like sending out the SMS will be done in parallel. So for that we need to initialize Threadpool executor over here. Next is the important part where we actually are starting to process the video stream, right? So this is live camera analysis. So in this method, we are accessing the live camera and getting the video, and we are processing each of the frame to detect a movement. So let's go and look into this method now. Okay, so this is here. So the first thing, as I said, that if you are using IP webcam, then it has to be RTSP, that is real-time streaming protocol. So I'm using IP webcam, and I need to provide the RTSP URL for the same to access the videos from that camera. So this is where I'm defining the URL. Okay, so the actual URL lies in the app config file that is provided along with this application. So it is, if it is in the cam mode, then I'm trying to use the RTSP and trying to read the video from here. So this is the line where I'm trying to read the video. Okay. Now, as I mentioned earlier, that we need to have a base frame, that is the first frame has to be captured and it has to be kept in the application so that it can be used for comparison at later stage. So this is where we are trying to capture the first frame. Okay, let's go further. The important is the while true because we are running the while loop to access each of the frame from the video. So the first line that you see is vid.read, and that is where I'm reading the first frame. So this is the first frame that we read, right? And the first thing after that we do is convert it to the uh, gray color image. So this is where we are converting to the gray color image. Then to filter out the noises and smoothen the image, we are applying the Gaussian blur filter. So this is where we are applying, and we get the gray image again. So if the first frame is still none, then we have to assign the first frame to the current frame to the first frame. This is what we are doing at the start of this application, right? And then we are, actually trying to detect if there is any change using the method detect movement. Now in this, what I'm doing is I'm passing on the current frame. This is gray, and the very first frame that was captured. Okay, this is what I'm doing here. Now let's go into detect movement. So here it is the current frame, and thus is the initial or the first frame that was captured. Now in this, what we do is we get the difference of the two frames. That is, we subtract these two frames. If you see cv2.abs_def, and we are passing the current frame and the initial frame. So we are trying to get the difference, right? So once we get the difference, we are just resizing it so as to make the entire computation less resource intensive. It will be faster if you do that. And then we, as I said, that we will be thrashing out. That is, we will be applying thrashing to convert all the pixels above a certain value to white and all the pixels below that certain value to black, right? So here, that is what we are doing, and once we do that, we again dilate the entire image. This is what we are doing, and then we try to find out the contours. That is, if we find any contours in the subtracted image, then we can safely assume that there has been some movement, right? So this is what we are trying to do here. We are trying to find the contours on the subtracted image. But at the same time, you also need to be sure that the movement has not been due to some noise in the environment or some noise due to the camera. So for that, you need to filter out those contours which are less than a given area. So here I'm using 50,000 as a threshold. So if some contours are below 50,000, then I'm just ignoring it in this block. But if it is above, then that means there has been movement, and you have to set this flag is movement detected to true if that is more than 50,000. So once you detect that there has been movement, then you also need to check if the movement has been detected because of some change in the light. So after you detecting the movement, I'm going to check if this movement has been due to light or it has been really due to some objects coming in the way. Okay, so let's look into this if the movement has been due to light. So what I'm doing here is I'm just passing the subtracted image to this method, check if lights started. So let's look into this. So this is the def image that we have, and what I'm doing is specifically over here is on this image I'm applying thrashing, right? So if, let's say, in the area, if you've turned on the light, that means that the area where your light lies, at that point the pixels will be very bright. I mean, it will be almost close to white or 255. So if I apply a thrashing wherein I'm giving the threshold value as very high, close to 255, let's say in my case I give it as 180. So all the pixels above 180 value will turn white, and all below will be black. So in that case, if and on top of that, if I'm able to detect some contours, that means that light has been turned on. So this is what I'm doing here. And also I need to check if the contour area is more than certain specific threshold. Like in this case, I'm keeping it as 5,000. So if I detect that, if it is more than 5,000, that means the light has been turned on. So this is what light has been turned on. And this method returns the light turned on as true. Let's go back and look into this method from where this has been called. So this is what here it is. So if light turned on, I'm checking here. If it is turned on, then I say the motion detected is due to light. Let me put it as detected is due to light. So in that case, what I'm doing is I'm just invoking a parallel a method to do some parallel operation. In this case, I'm just calling do parallel task, and here I'm passing the current frame here, right? So this is, and also I'm telling that it has been due to the lights being turned on. If it is just a motion detected, not because of lights being turned on, this last flag is false here. You see this one here. So let's go into this method. Okay. Now here, what primarily what I'm doing is I'm just taking this frame and then saving it in the output folder. If you see, this is the output folder. Here I'm just saving the frame. It is like this. Here, let me go down and show you where I'm saving. This is where I'm saving the that current frame into local folder, and then after that I'm just uploading it to AWS. This is the method where I'm trying to upload to the AWS. And so once it is uploaded, I have the URL of the same. Uh, this is the URL I'm creating, and then this is again sent to Twilio service so that it is sent out to the actual user, and actual user gets a message with along with the URL of that the image which has been snapped, which has been taken at that particular point of time. So this is how the entire application is going to work, and I'll be sharing this entire code on the GitHub, and the link for the GitHub will be there at the bottom of my YouTube video. So you will get all those things. So now what next? Next, what we are trying to do is after this, in my next tutorial, what I will be doing is I'll be doing not only just the moment detection, but it is kind of an object detection that will happen, and that we will be putting on the NVIDIA Jetson Nano. So everything from now on will be on the NVIDIA Jetson Nano. Again, there also we will be doing the analysis of what has been detected, and if we can really find out if there is some person in the frame, can we try to find out who the person is with the help of image classification as well. So all these things we'll be doing in my next tutorial, next video. Okay, thank you so much for watching this.